Yes. Yes. Welcome to day 8 of 30 days of symmetry. Today is, what are we, October 29th. We're getting into the creepy, hallowed end of autumn, the beginning of winter. So we're going to do something thematic today. We're going to do a little bit of some haunted work here. We're going to use Google Tiltbrush. We're going to use Google Blocks. And we're going to create something like this. The main features of which are these eyeballs that follow me everywhere, that keep looking at me in VR as I move around and fly by this character, or move. If I getting close to it, it goes cross-eyed and stares at me. I can even get inside of it, and its eyes are penetrating my soul. So what we'll be working with is Google Blocks, Google Tiltbrush. We'll set up this kind of this night scene. We'll set it up with the script that makes it look at me, and as a bonus, I will attempt to recreate this hinged jaw audio reactive little setup here, and we'll also do a little bit of material work, just getting these awesome eyeballs to kind of to be very what we call specular. See that, and glossy. You see that reflectivity from them that just looks like the wet eyeballs of something living. And I also did another little effect that makes the light on the eyes glow extra bright when you get closer. And so these are all the things that we're going to learn today. The actual interactivity, the script is the script itself is called Look At. So we're going to be using Look At. I'm being told that the live stream is not happy at the moment. So I'm going to actually stop this and... oh wait, no, I'm being told it's okay. I think sometimes it takes a little while for it to all to even out. Maybe I scared the stream a little bit. Just checking to see if I should be if I should repeat things. It looks like my technicians tell me we're doing fine. So again, we're going to learn about Google Tiltbrush. We're going to pull in this awesome skull, and we're going to pull in this is a skull by a user on Tiltbrush, known as, let me pull it up here. I've got it in the Discord channel. Tekano Bob made this skull in Tiltbrush, and he's open sourced it, so it's public and remixable on Google Poly. And the eyeballs were made by Jeremy Eyring, and we brought him in and made him a bit glossy. And yeah, so those are the two that we're going to be using, and I'm going to teach you first about this look at concept that means that wherever I go, these eyeballs follow me. Those eyeballs are constantly looking at me in my in the VR world here. I'm going to first teach you about that, and then I'm going to teach you about importing from Tiltbrush and importing from Google Blocks via Google Poly and via Tiltbrush. They're going to have a little bit of a slightly different import process, and that'll be kind of important to understand, and how to work with the mesh and kind of get it. Boy, let's see here. Sorry, excuse me. How to get the mesh into the right position and usable. I'm gonna hit escape here and kind of come out. I'm gonna save this, and we're gonna go to a new project. I'm gonna turn VR off, and I'm gonna make sure that I just had my external monitor, my second monitor, that's helping me just go get really shy. It just turned off. I'm gonna bring it back up so I can keep an eye on the monitor, the Discord channel. Excuse me. All right. Let's return to Simmetri, and all right. So we're gonna begin. We're gonna start by learning about what is look at, and look at is this is what's making those eyeballs look at the VR character. And so I'm going to teach you how to create that, and I'm also going to show you that there is indeed a shortcut here under UI game called look at. So we're actually going to start with this, and then we're going to kind of dissect it and create it in our own way, because you might want to know, you'll want to know how to use this look at concept for maybe not in this simple point and click automated way. You might want to use it in different ways, and it's really pretty simple. It's essentially one line of code, and the effects can have there can be some really cool visual effects. So I'm here in a new Simmetri world, and in the center of my screen you can see when I press G, G toggles. Actually, here let me get my input callouts. There you go, in the yellow. Now you can see when I press G, I can toggle grid view on, and grid view on lets me see this axis in the world, which means that I can see that Z is moving out in the positive direction, this direction. So this is more positive Z. This is negative Z. Positive X over here. Negative X over here. And obviously positive Y, negative Y. Okay, so the reason that we need to kind of think about our coordinates is because for each object it has an inherent frame of reference that starts off oriented with the world and then kind of changes from there. And so when this thing is going to look at something, it's basically going to say, that part of me that's facing forward in the Z direction, I'm going to face my forward side, my front face. I'm going to point it at something else. So I'm going to give you an example. Well, let me make these a little bigger. I'll make a sphere over here. So if this box wants to face that sphere, it's going to rotate the part of it that is facing forward in the Z direction. It's going to rotate that to point at that sphere. So let's I'll set up an even more big and obvious version of this. So if I go and I get let's draw a box, and I'm going to kind of draw it lengthwise across the x-axis. Now I'm going to draw what I'm going to kind of consider like eyeballs. I'm going to kind of put them on the front side here, and then I'll put like a nose made out of one more, and then I'm going to fuse these together. I'm going to select them all and hit Control D, which fuses them into one entity. It fuses them into this single block. They share a mesh and they share a rigid body so that they kind of work as one contiguous object. Okay, so now that I've got this object, I'm actually going to, because I'm going to be setting its rotation using this look at script, that means that it's going to have to fight physics. Physics is going to want to pull it with its rigid body. It's going to want to, gravity's going to want to pull it down. It's going to want to topple forward. So if I'm going to control its transform, whether that's its rotation or its position, if I'm going to control that via script, telling it where to look and whatnot, I'm going to pretty much be fighting with physics. Physics is going to say, hey, tip over because you're heavy. And then my script is going to say, no, look over here. Look at this object over here. And then script is going to say, look over here. And then physics is going to say, no, tip over. And it's going to say, look and tip over. So those two, they will fight every frame. And so you kind of need to pick a regime, kind of pick a plan for how you're going to tell objects to be transformed in the space, how they're going to rotate and where they're going to position. So your three options for those are through script, something like the look at script that we're going to do, or through physics. When I'm pressing play, physics is just figuring out where the heavy side of this is, where its center of gravity is, and it kind of takes on the collisions, and it's the physics engine telling it where to go each frame. So script or physics or a timeline. And if you make a new key track on the timeline and give it a position, Simmetry's smart enough to know, hey, you need to turn your rigid body off, so it makes it movable false. So all this is to say that if you're going to, I'm going to get rid of this track, if you're going to make this thing look at something else by script, if you're going to rotate it and affect its transform by script, then you probably don't want to control it by timeline, and you don't want to leave it up to physics. So the way that you can take physics out of the equation is turn its rigid body either to active false, or it can be true and movable should be false. Or active can be false and movable can be true. So it's basically false, this is completely inactive, doesn't matter what this is. If this is true, this can be either. And even more so, you can get rid of the rigid body completely. And now nothing will collide with this. Nothing will intersect it. Gravity won't touch it. And this is how we're going to do it. Okay, so long story short, we just created an object that faced forward in the Z direction. It's got, this nose. It's got these two eyes and this sort of face object. And we're going to make it look at something else. And so we created this object, we fused it together, and then we went to its rigid body and we deleted it. I'll add back a rigid body so you can watch that one more time. Rigid body, came to this little triangle, and we hit remove attribute. So let's remove the attribute so that we can now have this thing look at something else. And when we remove the rigid body and we press play, this thing can float up in the air. Gravity won't affect it. Cool. So we're going to use the built-in script just to give you a sense of what's going on. And I'm going to give it something to look at. So I'm going to use the actor movable ball. And this I can move around using W, A, S, and D. And you'll see my keys down here when I press them. W goes forward relative to the screen. D to the right and left. You've used this rollable ball if you've gone through the Learn menu. So if you go through the Learn menu and you've gone through the Intro to Basics, which you must do, and really if you're watching this and haven't done these, I highly recommend, and you almost need to kind of get yourself through a good amount of these first. And they're fun. So anyway, we know how to move the rollable ball with W, A, S, and D. And now we're just going to make this thing look at it. And so what it does is basically it's going to set this rotation procedurally, programmatically, based on where this position is. And so, again, its front face is wherever's pointing in the Z direction. And so I'm going to use this, I'm going to use our simple, what we call a user interface extension. It's just this little thing under UI game, which is look at. And you see when I click look at, it says pick the looking node. Well, looking node, this is the one that's going to be the one looking. So that's going to be our little frog-faced thing here. And then it says pick the node to look at. Well, I'm going to pick this one. And this is a nice little script that kind of sets it all up for you. And what it's done is it's put this little script node under mesh entity, which is, I'll call this face. And this is ball. So now face is going to look at ball. And We'll open up the script in a second, but let's take a look at what it's doing. So here we go. Here we go. So we roll the ball around, and you can see that it not only tips kind of forward, it also spins to chase this ball out, looking at this ball. And as soon as it gets right underneath itself, it kind of ends up snapping to one side or the other. Pretty cool. And the other thing that's kind of cool is if I copy this, clone out a bunch of these, they all dynamically look at this same ball. And if you set the node to be looked at to be you, the person in VR, you'll start to understand how we got those eyeballs to look at us. Now in this little lesson here, I'm teaching you that it's a whole face that's rotating to look at you, but we're going to just make it a single eyeball. So let's take a look at this script, and let's recreate this on our own. So first of all, I'm going to delete all these copies, just so we're only dealing with one. Clear up a little memory. Should take it a second to wipe them all clean. Okay, so now we've just got this single one here. So if we look at this look at code, I'm going to right click on the look at node here in the hierarchy, and I'm going to hit edit code, and that pops up the Lua scripting window. And we're going to write ours in a slightly different way, but it's going to basically contain the same elements. What you want to look at is basically right here on init, when the world starts and this face object initializes on initialization. When it first gets kind of placed in the world, placed at start time, it runs like immediate code right before it plays. And what it basically does is goes and gets the ball. It goes and gets the thing it's gonna look at, this look at point, and then later, it's going to go and look at that point. So the look at object is the sphere that's being looked at. And the way that the look at function works is it needs to see, this is the sphere, self.lookAtPoint. Self.lookAtPoint is, and that's the object. This got figured out when we clicked on the look at point. So self.lookAtPoint is referencing this sphere. So when we run this function down here, self.lookAtPoint is the sphere, and when we go and get its world position, we do that every frame, and as it moves, oops, excuse me, maybe click outside the Lua window. As I move, this sorry, I overwrote my script. Every time this ball moves, on every frame when this function gets called, this object, this sphere returns a different position. So the sphere keeps returning a different position into this place right here, and then so this object keeps rotating to look at a different position in the world. So we're going to write this from scratch and do it in a slightly different way. So I'm going to actually delete this look at. That's the automated way, and it's under UI game. So under UI game category, look at, and then you pick the looking node and the node to look at. We're going to write this on our own, and it's going to be very straightforward. Basically, this object, the face, has an event on its top level. So if I go to its properties and I'm on its top level, when I come over to events, it's got 4 basic events on init. That's when it first gets initialized, as I was describing. On tick is every frame. On move, if it moves. And then on render, so this is if it's actually in view. So we're going to use actually on tick for this one. And this will happen every frame. And basically what we need to do is get a hold of the looking object in our script. So we're going to select the ball, because that's the target of our looking, and bring it into the script, grabbing its icon and dragging it into the script. And so we need to call the lookat function on ourselves, which is self : lookat with a capital A, open close parentheses, and in these parentheses we're going to type the following. We're going to get the ball. We just need to give it a position in space to look out at. So the position in space is going to be the world position of our sphere, which is now called ball, all caps. And we're going to say : get world position, open close parentheses. So the ball, we go and get the ball, we go and get its world position, and it returns a vector 3 of its position in the world. So it returns its transform. It returns this. Then this item knows to rotate to point at that object. And on tick means it's happening every frame. So this should have the same effect as the last automated version. And sure enough, it does. And if we make multiple copies, they too stare down like panopticons. Which is pretty cool. So that's the main effect. It is really that simple. It's this simple right here. Go and get the target. I'll write a comment with 2 hyphens. In Lua, that doesn't get called. You get the target. Call lookat on looking object. Pass in world position of target object. Cool. You could also do this a slightly different way, and this is worth knowing. Right now we're editing the code on the face itself. So it's this face that has the on tick event. So face, properties, top level, the event, on tick. This means every frame it's going to run this. Well, we don't need to actually run this every frame, and I'll show you why. We can actually spend less computational power if we only do this when this ball moves. When this ball moves, that means it's got new information to give this object. So what if we just cut this? We'll cut that code out of this face objects on tick. And what we're going to do is instead run that code on the ball. So on the ball, top level, ball, properties, top level, events, it has an on move property, which is on tick will happen every frame. On move happens only when its position or rotation gets updated. When its transform gets updated, the on move event is called. And if the on move event gets called, this function gets called. Yeah. So what that means is, what if I say, when I move, now you face, you should update. And then if the ball sits still, then it's not running script. It's not running script 90 times a second, 90 frames per second. It's just only doing it when this thing moves. So in this case, we sort of reverse course. I'm actually not going to paste it in because we can write it so simply. We basically are going to say face, and the face, we've dragged the face in now because where our script is living on the ball. So self will be ball, and face will be the thing that needs to look at. So in this case, it's not self colon look at, it's going to be face colon lowercase l, look uppercase A, T, and it needs to look at me the ball. This on move event is on me the ball, so me the ball is going to be self colon get world position, open close parentheses. So it's just happening from a different perspective inside of the structure of these objects in the world. And so the code using self to reference myself is when I'm on the ball, and when I'm on the face, self represents face, and ball is going to represent ball. So this is the other way of doing it. So when the ball moves, we go and get the face, get a hold of it. We tell it to look at our self get world position, our own location. So let's check this out. Same effect, same exact effect. We just put the code in two different places. So that's interesting, that it can have that effect. And again, on this one, there is no code sitting over in face in onTick. In fact, I can delete that entirely. And in this case, the code is all living on the ball, and the ball goes and gets the face. On the last one, the face went and got the ball. So there's different ways you can set up your scripts. You just need to know that if the script is being run on this event or on an interaction under the interactable, on like an on-press event, that self is the object on which this lives. So ball, if it's an on-move event for the ball, self is ball. If it's an on-move or an on-tick, or if it's on press, that's going to be, and it's on the face, self is the face. So there you go. So that is basically the simple coding lesson today. There's two real concepts in there. I mean, one of them is the symmetry look at function, and the other is, really depending on where you place your code, you'll end up having to kind of have a different, the references, the relative reference of what self means is slightly different in each context. And then lastly, it's important to know that basically at this point, when the ball is not moving, no code is getting called in this construction. So it's actually more optimal and using less computation. So that's it. You can run script in different contexts. You can run it at different moments on different events, and you'll end up with either the same or similar effects. Sometimes you can get the same effect for less overall computation. And Amadeo will call that incurring a penalty. If we use the onTick event right now, while the ball isn't moving, and we don't need to update the position of this object when the ball stops moving, we're incurring a penalty while this ball sits still. When it sits still, we incur a penalty that we wouldn't otherwise need, because once it sits still in this structure when the code is on the ball, we are not calling this onMove function. The onMove is not getting called. The onMove gets called effectively. If this ball sits still every now and then, the onMove gets called less than the onTick event. So putting a ton of onTick events can sometimes be costly. So that's an alternative. Okay, so let's learn about how to bring items into how to work with Google Poly. We're going to bring in the skull, and we're going to bring in the eyeball. The eyeball is coming from Google Blocks, I believe, or it's a model coming in off of Google Poly from a contributor. And the skull we're going to bring in from Google Tiltbrush, so you'll learn how to do both of those. First, let's start with Tiltbrush, and I'm going to show you the process for that. So I'm going to actually just go to a file new, and we search Poly. We jump out to the website by holding down Shift-Control-P. or under Edit Find, you can search Google Poly. So Shift Control P, and it'll bring up a little search dialog here. Oops. And if I type skull, it's going to open up. The Google Poly window here, and I'm looking at some skulls. I saw this cool one by Evolve from the Wave. I was thinking about using that one, and then I decided I really wanted to demonstrate some stuff in Tiltbrush, and this one looked extra creepy, and this is by Tekano Bob, and pretty solid. Pretty good creepy work. I also like he's made this one public and remixable. This eagle. Here's this eagle. Pretty awesome. Maybe we'll do something with this a little later. So we're gonna go with this skull. So you'll notice that it says it's public remixable with the Creative Commons attributions license, and you can learn more about that. What that means is that you are going to give a shout out wherever you use this, and embed, an attribution to Tekano Bob wherever you can. And what there is, the question is though, how do I get it? Well, in this case, you own Tiltbrush. So Tiltbrush will require you to snag this in the Tiltbrush app, and then I'm going to show you how to export it. The eyeball, we'll search in here. The eyeball that we're going to use is by Jeremy Eyring. I like this one because it has some realism to it, and actually has this is an uploaded 3D model. So this definitely wasn't from Blocks, but it's being distributed, public remixable on Google Poly. And so this one's pretty cool. And so for the eyeball, you'll see that we can download it. So let's go ahead and do that. We're going to download the eyeball and bring it in first, and then we're going to bring in the skull. So let's go download. What you're going to do is bring in OBJ. And we did this at the end of Saturday's lesson when we went to the moon. So we're going to download this. I put it in 3D models under a folder called Google Poly. And then I always just title it with the same convention. In fact, you see the one that I just brought in earlier. I'm going to pretend hit save because I've already got it in here. But you'd hit save. I do the name of the, so that I can give attribution, I do the name, and then I do underscore, the title of the author, the creator. And you can see other places, Computer Room by Bruno Oliveira. So there. So anyway, I would hit save, and then I'm going to import that. So that saves down as a zip, and that's fine. We're going to use import optimized, and back in Simmetri, we're going to import optimized, and we're going to come. I'm in my 3D models, Google Poly. This is the place where I saved it, and we come down to the zip files, which live under the bottom here, and I'm just going to go straight to eyeball Jeremy Eyring. I wonder if that's how it's pronounced. Maybe it's Eyring. And I've got this eyeball, and we're going to see if we can get the look at to work on this thing first. So as Google Poly comes in, so when you're working with Google, with any of these, and we'll do a different set of fixes on the mesh that comes in from Tiltbrush, we have to get our model to work the way we want it, look the way we want it when it comes in. These models don't know up from down. They don't know which direction the 3D program that they're getting made with or exported with considers up. So the data can come in kind of weird. They don't know where their center, what they call their pivot. They don't know should I rotate at my bottom, or should we consider my center? That all kind of matters to the artist, and the artist, has embedded it in a certain context. Context meaning there's different reasons why you might want the absolute like 0 of this model to be at the absolute bottom. There's other reasons why you might want why you might want the absolute 0 to be in the absolute center of this mesh. And it kind of depends, mesh for mesh, object for object. And so what you need to do is prepare the data in here. And so what that means is basically getting it set into space, sized, and getting the pivot point. It's considered its 0 point, and getting it to basically face in the right direction and be organized the right way. So I consider that just preparing the data. And we've got a lot of tools that are actually pretty easy to use to get you set up. And so to do that, what we're going to do, and like I was saying in the last little piece here, the last segment of this tutorial, is we're going to have something look, because the eyes are going to they're going to rotate to look at something. And so let me just show you what that might be like. We're going to bring that actor movable ball in again. And then we're going to use the UI game, the look at, and we're just going to click on the eyeball, and then we're going to click on this on the movable ball. And when we press play, you can see that it's rotating, but it has maybe an undesired effect, maybe not. I don't know. It's kind of interesting. It's pivoting around that, like almost like it's a helium balloon or something, being held by it, with like a really small string. But it definitely is not looking in the right direction. It seems to be off by like 90 degrees or something. It's super confused. So this is the thing I'm describing. That model is not ready for us to really tell it where to go, because it's not facing the way that we want it facing. So let's get rid of this look at node, and let's begin to process this. I'm going to get rid of the movable ball too. So I'm actually going to come over to the excuse me. I'm actually going to come over to the front, I'm going to move around to the positive Z direction, and you can see, let me just pull this out. You can see it here. In fact, we're in the shadow, and so if I move to the positive Z direction and face back in the negative Z direction, meaning I'm kind of facing the front facing. If something's facing out in the Z direction, I want it looking directly back at me. I'm also looking directly back at the sun, because we usually set up a symmetry show to look in the opposite direction. So I'm gonna move the sun around. And how do we do that? I'm gonna click on the ground. I'm gonna click in the sky, and under surface location, I'm just gonna go to the southern latitudes. There we go. I'm gonna go down to Argentina or something and put the sun. The sun is now coming from a different direction. Okay, so I am looking in the negative Z direction. So if I were to take this object and pull it in the positive Z direction, it would come towards me, yeah? And if I negative it, it goes away from me. So if it's looking in the right direction, when it looks in the right direction, it should be staring straight at me. So what I need to do is get this mesh data to just stare straight at me. So to do that, what I'm going to do is actually just get it centered, get the data to center around its own kind of geometric center of all this data, and then I'm going to then work on the rotation. So let's get it into right above this coordinate and see if it's right above that coordinate. So I'm going to take the X and double click it so I zero it out. I'm going to take the Z, double click it, and see if I zero it out. And I can already tell that it's off. It definitely wants the bottom of the eyeball or something to be against this edge. And so what I'm going to do to work with this data is a series of what are called mesh modifiers. So if you select your Google Blocks, or the model, the 3D model that came in from Google Poly, under its mesh model is a thing called mesh modifiers, and these things are additive. So you can add multiple ones, and they will adjust your data additively, kind of in series. So the first one I'm going to use is what's called a line pivot, and a line pivot is object that around which it pivots. So if I undo that, what do I mean? Well, remember it was like a balloon getting pivoted around, like it's the like where you inflate it. I don't want that. I want to like when I rotate that, I want it to just kind of spin on its. I just want it to spin and not really like revolve around a center point. So I'm using. I had undone that, so there is this vertex transform mesh modifier is here inherently, and it's an attempt for Simmetri to scale things into something slightly realistic. And this one could actually downscale, and we'll do that in a second. But what we're going to do is click on Mesh Modifiers, and we're going to add a line pivot. So a line pivot puts the it chooses the extent, kind of the bounding box of this sphere, and it says put me in, with respect to the x-axis, left to right, put me in the center of that. But if I wanted to be on the minimum of it, now I'm sort of doing. Now you can see that this pivot point is kind of based on the x's side. So I'm actually gonna I'm gonna hit center, and I want y on the center. So basically, center, center, center will put the pivot point at the exact middle of this object. And now when I rotate it, it's doing what I want, right? It's got that. It just spins kind of on its axis. But I want to make sure that I don't spin it. What I want to do is put its actual transform. I want to zero out its actual transform, and on the x and on the z, I'll leave the y so that it floats above the ground. But I want it kind of in the center of the space with respect to x and y, kind of, or x and z, excuse me, on this plane, on the ground plane. And then I don't want any rotation because I'm going to fix this rotation once and for all. I'm going to fix it so that it works in my context. So I want it to point, I want this eyeball to point at me when I'm forward in the z direction, when I'm out on this blue axis, when I'm forward on the z direction. So I need to come to this mesh modifiers and add another vertex transform. And if I'm on this vertex transform and I come to rotate, I can try to get it to rotate where I want it. So I'm actually going to say, no, it doesn't seem like y is the one I want. I want to do, let's try x. So I went forward. I'm going to guess it's dead center on 270. And this is what I want. Now it's looking right at me. And the effect of an eyeball is so instinctual that when you get it to face you, you know, you feel it peering into your soul. And so now the eyeball stares in the forward z direction. It looks forward, and seems like it's not looking up or down. It's looking like out in the forward direction. And this is a great model, by the way. I mean, really. It's even got kind of this lensed edge to it. Anyway, so it's now facing forward. We can work with its scale later on. Now we can just kind of scale it using our transform scale and whatnot. But the main thing to know is that our transform is zeroed out. So our transform is like in its like native state. Like it's not rotated or anything. So if I add some programmatic rotation to this, underneath it, the data has already been manipulated and normalized and prepared. Okay, so that was kind of the long route, but basically using two of these mesh modifiers and a line pivot, which put our eyeball's pivot point in the center, which allows it to rotate, in its center the way we would expect a sphere eyeball to do. And then we use the vertex transform because for some reason it was rotated in a different direction, and now it faces direct forward in the z direction. It faces directly forward in the z direction if and only if its transform rotation on the y is at 0, which is perfect. That's exactly what we want. Okay, cool. So this eyeball is ready to follow our movable ball actor. So we'll go over to Toolbox, Actor, Movable Ball, and then we will go to UI Game. We'll go to Look At, pick the looking node, That's the eyeball. Pick the node to look at. That's our actor, the movable ball. I right-click to exit drawing, press play, and I move the sphere, and that's just kind of creepy and awesome. And then, true to form, that's great. What's up, Four Eyes? Yeah. Super weird. Alright, so you can take a pause right here, and I think you'll find a lot of joy just like messing around with that. I'm going to delete these 3 eyes. We're going to come back and work with it. I'm going to go ahead and just clean things up and name this eyeball. Oops. Excuse me. Eyeball. Looks at the movable ball. Okay. So, yeah, we brought something in from Google Poly, and we got its data ready. We got its pivot working, got it kind of centered the way we wanted it, and then we got it rotated to face in the direction we wanted, and now it behaves the way we want, which is really cool. Great. So now we're going to work on Tiltbrush, and to do that, I'm actually gonna save right here. File, save as. So we're gonna go to Tiltbrush, and I think we were just there. We were here at eyeball, and then we wanted to go to skull. So how do we bring in a Tiltbrush model that we find on Google Poly? Because it doesn't have a download. So the way that this works is you've got an account that's related to your Tiltbrush account. I'm actually going to have to switch accounts. This is the account, my Simmetri account, related to my my Tiltbrush account. So based on which account you link to your link to Tiltbrush, that's the one that you're going to need to be logged in on in Poly. And the way that this works is when you go into Tiltbrush, and we'll show you this in 1 second, it can pull in a list of the models that you like. And if they are public and remixable, you, under the same rules of Creative Commons attribution, can work with them. You can actually then paint over them in Tiltbrush and add to them, right? You can remix. And in our case, you're going to pop them out of Tiltbrush and send them into Simmetri. So we're going to do, hopefully this works. I'm going to stream out an image of Tiltbrush. So let's see. So the main thing you need to do is find this one. If it's creative, remixable, public, remixable, Creative Commons, you just need to like it, and then it'll show up in your account when you go into Tiltbrush. I'm going to save Simmetri, and I'm actually just going to close it for the moment, and we're going to come back into this in 1 second. I'm going to load up Steam. Actually, let me shut down Steam VR entirely. Just do a clean exit. My Steam on my computer sometimes gets a bit fussy when VR's running. It gets a little confused, it seems. Hang on, waiting for Steam. Library. Just not too many on this account. What we're going to do under this, we're going to play Tiltbrush. So, Tiltbrush should load up. Still a white screen. G4.